Hey everyone, it's Miss Goobrood. This is Unit 2, Lesson 2-4A. We'll have part B tomorrow, finding the area of any triangle. So as you can see, I'm already on the CAMI document that goes along with your book. You also notice that I have our book here because we have to do it hard copy. This is not going to work well on a CAMI. In fact, it's even really hard for me to show you on CAMI. So you've got to go into your student activity book today. If you absolutely don't have it and you can't print it out, do your best, but it's really, really going to be hard if you don't have a hard copy. So try to get it in a hard copy. Okay, first thing they're going to do is carefully and neatly cut out around these triangles. So you're going to have to cut around the outside edge. Don't leave a lot of white and don't dive into the colors, like don't dive into the blue or into the purple, but grab your book, look for page 69A and cut out these shapes with me. I'm going to do it too. Pause your video, go get a scissors, do it, and then come back. All right, here I am. I'm cutting them out. Try to cut as straightly and neatly and as much right on that line as you can. Try to make it neat and straight. I'll see you in just a minute when everything's cut out. All right, we're back. Hopefully you've cut your pieces out as well. So you can see that the acute triangle pieces, I'm going to make myself a little bigger here. There we go. Our acute triangle pieces are the ones that are kind of this bluish color. Our obtuse triangle pieces are the ones that are this kind of purplish color. In the last video, you learned about acute and obtuse triangles in the same lesson, but it's a different video. Okay. Now it tells us take our acute triangles and move them around, mess around with them a little bit, and try to see what shapes they form when you put the letters together. So if I put both B's together, what shape does that make? Well, if you've already had your small group with me this week, and if you've done your lessons from the last couple days, I hope you recognize that shape. But what happens if you put two C's together? The C and the C. Now what shape? Same name of the shape, but just a different kind of variation of that shape. What about both A's? If you put both A's together. So I want you to do this with the obtuse triangles and the acute triangles. Mess around with them. Get the letters to connect together. Find the two letters that match, like two X's, two A's, two B's, two Y's. Put them together and see what shape you make. Go ahead and turn them. Now, notice that if I put like a Y and an X together, it just kind of makes a weird messed up shape. Not really a shape that we necessarily have an official name for, although we could count the sides, 1, 2, 3, 4, 5, and call that a pentagon, but not necessarily a shape that's a traditional shape that we're used to seeing. So make sure that you're putting the letters that match together. Do that, mess around with that, and come back in just a second. So pause, do that, come back when you're ready. All right, you're back. I hope you noticed something. I hope you noticed that no matter which letters you matched up, you always made a parallelogram. Putting those two triangles together, no matter whether it was an acute triangle or the obtuse triangles, when you matched up the similar sides, the same sides that were the same length, it made a parallelogram. That's really, really important because we know how to find the area of parallelograms. So if you can put two triangles together and make a parallelogram, we're well on our way to being able to find the area of a triangle that's not a right triangle, that's any other kind of triangle. So please turn with me now in your book to the next page. So have your book open to page 69, and this is a tricky one. This is one that we would have done together even if we were in person. We would still kind of work through it together because it's tricky. So what I invite you to do is you need to have your pencil, and I'm using red hopefully so you can see it easier. You need to have your ruler Now, your rulers were sent home with you from Miss Domask in the supply pickup bag, maybe a couple weeks ago. So if you don't have it, go and check with your family because you need to have a ruler. And since it's measuring in centimeters, the directions are going to tell us measure in centimeters, it has to make sure that it has a centimeter side. So double check that you have a ruler and your book, and then you'll be ready to go. So if you don't, pause the video, go get those things, come back. If you've got your materials ready, let's dive in. All right, I'm going to turn my computer down so you can see my book easier. Now, the first, we're going to try to draw parallelograms and triangles. When we used these materials that we just cut out, we weren't drawing, we were spinning them around and working with them. And those are the really important things, ways to help our brain understand what we're trying to learn. That's super important. But now we're going to try drawing. And as you get into middle school and high school, you're going to do a lot of drawing with geometry. So let's get started. It says, answer the following questions about triangle ABC. We name triangles by their corners, their vertices, and we can name it A, B, C. We could also name it B, A, C, or we could name it C, B, A. As long as we name the three in an order, that's the triangle. So here's triangle ABC. Number 1 says, measure and label side AC. So that means we're looking for A and we're looking for C, and it wants us to measure it in centimeters. Do that now. Push pause. You're going to be pushing pause and doing the work, pause and doing the work, and coming back and seeing if you agree with me. So don't just watch me do it and write down what I do. Please pause and do it yourself, because here's the deal, friends. I already know how to do this. So I'm not the one that's learning something new here. Okay. Well, actually, if you teach it, you learn it the best anyway. But please pause and do it yourself and then see if you agree with me. So don't let me just do it unless you're super confused, in which case watch me do it and then do it. But if you've got an idea about it, start with that, pause, and then see if you agree with me. Okay. So pause and try to measure. Here it is. Try to measure line from A to C using centimeters. All right, so we're going to, on our ruler, notice on your ruler, the end of the ruler very often is not the start of where you measure. There's some extra material. Oops, can you see that? There we go. There's some extra material on the end of my ruler, and there might be on yours. So I need to start right where that first cross hatch goes, right there, not at the end of my ruler. Then I'm going to measure that cross hatch. I'm going to put that right up on the vertex A, and then I'm going to line it up and see where it stops, where vertex C is. Now, it looks like it's 7 centimeters. So I'm going to go ahead and write that. 7 centimeters. So I measured and label side AC of the triangle. There it is. So I'm going to actually put it right on my picture. 7 centimeters. There it is. Let's go on to number 2. Measure and label the height. Again, pause here. I'm going to pause briefly. I'm not going to actually even stop my video, but you pause the video, try to do it yourself, and then come back and see if we agree. Measure and label the height. Now, we know that the height is from the very bottom to the very top. And it's not, you saw me, it's not leaning up against the wall. It's not leaning up against the wall. It's from the bottom in a perpendicular line, a square corner, straight up to the top. So there's the height. So again, I'm going to leave off that part of the ruler because that's not actually part that's measuring. I'm going to start where it says start here, start measuring, and I'm going to go from the bottom up to the top, and it is 4 centimeters. So I'm going to write that where the height goes. 4 centimeters. Go on to number 3. What is the area of the triangle? Holy cow, the area of the triangle. Well, you know what? We're not sure. We haven't really worked with areas of triangles yet. We're going to put a circle around that one and come back to it. Okay, let's put a circle around and come back to it. Now, use your ruler. Number 4 says, use your ruler to draw a line segment. A line segment is just a line that starts and stops through B. So we need to go through point B that is parallel to AC. Parallel, remember, is like railroad tracks. So it's got to go parallel to AC. So there is AC. Now, pause, see if you can figure out how to do it, and then come back. All right, we're going to put our ruler parallel to AC, on AC. There it is, right there. As a matter of fact, I'm going to even extend the lines of AC out further so we can see that big, long line. Now, the directions for number 4 says, use your ruler to draw a line segment through B. So we need to draw a line that goes through vertex B that's parallel to AC. Would this work? No, it wouldn't, because it's not parallel. What about if I just drew a line right here? Would that work? No, because that doesn't go through point B. It has to be parallel to this line, but it has to run through letter B. So you're going to have to use your ruler and slide it up carefully, trying to keep it as parallel as you can. It's not going to be perfect. That's okay. Keep it as parallel as you can until it's parallel and where you're drawing goes through letter B. There it is. So your line for number 4 has to go parallel to AC, and it has to go right through vertex B. That's tricky. Let's go on to number 5. Draw a line segment through C. Okay, I'm going to underline that. It has to go through C. That is parallel to AB. Now, parallel to AB. There's AB. We have to draw a line that's parallel to AB and goes through C. Pause and do that, and then come back and see if we agree. All right, let's try it. Draw a line segment through C. So we have to go through here. That's parallel to AB. There's AB. Oh, you know what? I'm actually going to pause and get a different color because that'll make it a lot easier for you to see. All right, I'm back, and I have green now. So now we're on number 5, a line segment that goes through C that's parallel to AB. There's AB. As a matter of fact, I'm going to extend AB a little bit so it's easier to see. That's the line that goes through AB, and it needs to be parallel to that. So I'm going to slide my ruler carefully along, keeping it so it's like railroad tracks, keeping it. What if I do this? Is that parallel? No, you can see those would cross. So I've got to slide both sides of the ruler at the same time, and I've got to keep sliding until I get to C. My point has to go through C. So that's pretty close. Now, it's not going to be exactly right because we're eyeballing it, but that's okay. There's the line. It goes through C, and it's parallel. These two lines, these two green lines, are parallel in the same way that our two red ones were parallel. Now we're done with that one. Let's go on to number 6. A related parallelogram has the same base and height as its related triangle or rectangle. So take a look at this. We've now made a related parallelogram. We took the first triangle that we had, and I'm going to kind of color it in here to remind us where the triangle was. We took that triangle, and if we had been using our pieces, we would have done what we just did by taking, here's our triangle. We're taking another one and we're matching it up and flipping it over to do that. We would have done that, taken it and put on a second one exactly like that. But we didn't have it in our hand, so we drew it. So take a look. The red triangle, what we drew by going through those points and making parallel lines is we did the exact same thing that we've done before with our pieces of paper. We now did that with our drawing. So a related parallelogram. So we've just created a related parallelogram. And it has the same base. Notice we didn't change the width of the base. It's still 7. And it has the same height. We didn't change the height. It's still 4. What is the area of the related parallelogram ABCD? What's the area of ABC? Whoops, CD. We forgot to label D. It says label D where the 2 lines come, so we forgot to do that. We got to put a little D in there. Now, what is the related parallel? What's the area? Remember, we know that parallelograms and rectangles are related. So we know that rectangles are base times height. We know parallelograms are base times height. So we've just made a parallelogram, and we're going to use base times height. So base, 7, height, 4. So we're going to do area equals base times height, and that is 7 times 4 equals 28. And now we see it's centimeters, so it's 28 square centimeters. The parallelogram that we made when we doubled our triangle, we just flipped it over and put another one over here, whether or not we did it with our pieces, or in this case, we drew it, we still just doubled it to make a parallelogram. All right, so here we doubled it to make a parallelogram. All right, let's go back to question number 3 now. How are we going to figure out what the area of the triangle is? We know the area of the parallelogram, when we doubled it, was 28. I hope you're saying, we're just going to take half of that. The triangle that they gave us was this red triangle. We made another green triangle, and we doubled the space to make it bigger and make it a parallelogram, and that's 28. We just need to cut it in half again because we only want the red. If the big related parallelogram is 28, what is the area of one of the triangles? Pause and figure it out. All right, if you're back, I hope you agree with me. It's 14. Half of 28 is 14, and it's still square centimeters. So it's still base times height cut in half. So the area of a triangle equals 1/2 of a group of base times height. Or we could write it another way, base times height cut in half, which is divide by 2. You may or may not know that the fraction bar is actually another way to write a division bar. Base times height cut in half, based on height divided in half. Let's go on to number 7. Use the directions in exercise 1 to 6 for this obtuse triangle. So we're going to do exactly these same directions, but now we're going to do it down on an obtuse triangle. So pause again without me. See if you can follow this whole process without me, and then come back. And then I'm going to go through the process kind of quickly. So pause, try to use all these same directions on this obtuse triangle. Then come back and I'm going to explain how to do it but I'm going to move kind of quickly through it and see if you agree. All right, let's go through it together. Number 7, use the directions in exercise 1 to 6 for find this obtuse triangle. So the first one says, measure and label side AC. So we are going to measure, there's AC. We're going to measure it. Using proper measuring technique, I get 3.5. AC is 3.5 centimeters. Next one, measure and label the height. Now, this is tricky. The height, remember, it's not leaning. It's a straight up and down. So the height, even though the tallest part of the triangle is kind of over here. So we're going to measure over here. The height is 4.5 centimeters. Now we're on number 3. What is the area? We're going to skip that again. We'll come back to it. Number 4, use your ruler to draw a line segment through B. So we're going through B. That is parallel to AC. So here's AC. And I'm going to extend that line so it's super easy to see. My parallel line, there it is. Now I'm going to keep sliding my ruler up. Sliding as straight as I can. Striding. Don't let it twist. I'm making railroad tracks, but it has to go through letter B. So there it is. There's my line for number 4. Goes through vertex B, and it's parallel to AC. Number 5, draw a line segment through C that's parallel to AB. So here's C, and it needs to be parallel to AB. So now I choose AB, and I go across like that. Now I'm going to slide till I get a railroad track going through, a parallel line, set of railroad tracks going through C. There it is. There's my line going through C. There it is. Now, just like over here, remember, I had what we started with. This is the triangle we started with. There it is. I'm coloring it in red. That's the one we started with. And we really just doubled our triangle. Here it is. Take a look. It's in between the 2 lines that we drew. Look at that. That's kind of like these. We started with one. We took the other one and matched up the same sides, and we made it a related parallelogram. We doubled it. We had one. We doubled it. Same size, same shape. Flipped it over. And when we doubled it, turned into a parallelogram. Same thing down here. When we doubled it, we turned it into a parallelogram. Now, number 6 says a related parallelogram has the same base. So the same base, the base is still 3.5. It's still the same base right there. Whoops, my lights turned off. So it's still the same base, 3.5. It's still the same height. Look how tall this is now. It's still the same height. So it's still 4.5. So we're still going to use base area of a parallelogram is base times height. So we're going to do, in this case, 3.5 times 4.5. Now, if you're like, oh, Miss Cooperwood, stop right there. I have no idea how to do 3.5 times 4.5. I will tell you that there is a fraction calculator. If you open a new tab and you Google up fraction, or in this case, mixed number calculator, you can type the numbers in, 3.5 times 4.5, and it'll give you the answer. And you say, wait a minute, why is my math teacher telling me to use a calculator? The answer is, we're not learning about how to multiply fractions right now necessarily. We're learning how to calculate the area of different kinds of shapes. So don't let that part confuse you. If you're like, I don't know how to do it, I can't remember, no worries. Open up a new tab and go to your fraction calculator and calculate it. If you're like, oh, wait, no, I know how to do this. I know how to do this. Well, give it a try. Pause it. Give it a try. Come on back. All right, if you're back, hopefully you either calculated it out, you figured out how to calculate it out. Oops, I need to tip my screen down. Or you used it on Calculator Soup on a new tab. I will put that in our Google Classroom as a resource for us. And you found out that it is 3.5 times 4.5 is 15 3/4. 15 3/4 square centimeters. So that's the area of this related parallelogram. But we're not finished yet because we skipped number 3. We still have to go in and say, okay, but we want half of that. We want half of 15 3/4 because we doubled it to get the related parallelogram, but we only want the original triangle. So now go back to your Calculator Soup mixed number calculator, or do this on your own if you know how to do it, and figure out what half of 15 3/4 is. Do that now. All right. Hopefully you found that 1/2 of 15 3/4 is 7 7/8. You could have typed that into your calculator as 15 3/4 divided by 2, because a half a group is the same as dividing something by 2. So you could have typed in 15 3/4 divided by 2 gives you 7 7/8. Now, I'm going to tell you that the answer key uses even numbers. I'm not sure why they did that or where they got that, because when I measured it was pretty clearly 3.5 and 4.5, but they changed it to 4 and 5. So if you're looking at our answer key for the answer, you're probably not going to get the right answer in this particular case, which is kind of weird. But maybe they just, I don't know, maybe they measured differently with their book, and that was like an old edition. And when they made a new edition, they changed the length a little bit. I'm not sure why that is. So don't let the answer key trick you. The answer was actually, when we measured it together, 3.5 and 4.5. What can you do? Okay, let's go on to the next page. There we are. Now, we're going to do more measuring and we're going to do more drawing. So draw parallelograms and triangles. So now we're on page 70. So again, please do this with me. I'm just going to keep rolling with the video, but pause it, do that in your book, and then let me show you how to do it. Unless you're super confused, in which case you can watch me do it first and then do it. But if you think I think I might be able to do this, try doing it before I do it and then checking yourself. So we're going to go on to the next page here. I'm going to turn my page in my book. Number 8 says measure and label side AD in centimeters. So pause and do that now. Here we go. Side AD in centimeters. There's AD. Whoops, I was on the inches side. Don't let that happen to you. If you look and it looks like this, it's the big wide ones. Those are inches. These little tiny ones are centimeters. So if it says measure in centimeters, make sure you're using the centimeter side of your ruler, not the inches. I had that wrong. So measure and label side AD in centimeters. There it is. And it is 6 centimeters. Number 9, measure and label the height. Pause and do that. I'm going to do it here. Remember, the height is a perpendicular line from the base. It's a square corner straight up to the top. It's not at an angle. We don't lean towards the board to get our height measured. We go straight from floor to ceiling. So the height is 3 centimeters. Number 10. What is the area of parallelogram ABCD? Again, pause and do this on your own, and then come back. We know that area of parallelograms, because parallelograms are related to triangle or to rectangles, the area of a parallelogram equals base times height. So to find the area of this, we're going to do base 6 times height 3. Base times height equals 6 times 3, and that's 18. And remember, since we're finding area, it's square centimeters. We can't leave that label off. All right, let's go on to number 11. Join points B and D. Join points B and D. What does that mean? It means draw a line. Draw a line from B to D. Join points B and D. Again, pause and do this. Don't just let me walk you all the way through the whole lesson, because then who learns the most? Me. And who should be learning the most? You. So pause and do it. Join points B and D means draw a line from B to D. There it is. There's my line. I drew a diagonal line from B to D. Name the 2 triangles. There they are. There's a 1 triangle. There's the other triangle. Remember, when we're naming them, weirdly, we make a triangle shape. So we actually write a triangle shape. That's how we start, by writing triangle. So triangle, and then you use the 3 letters. So I have triangle A, B, D. Remember, you could name that triangle DAB or triangle BAD. It just has to have the 3 letters in there. Then I'm going to name the other one. Again, you have to start with the shape of a triangle, because that tells your reader that that is a triangle you're naming. So you start with the shape of the triangle, and that triangle is shape BDC, or could be CDB, or BDC, or DBC, any of those combinations, as long as it has those letters in it. All right, let's go on to number, oh man, I wrote those in the wrong area. Oh, crumb. I got to put a little arrow that goes up there and goes up there. I was writing the answer. Sorry about that, everyone. I was writing the answer for number 11 in number 12. So I put an arrow, so you know that's actually number 11. Now, number 12 says, what is the area of each triangle? Well, we know the area of the whole thing, this whole parallelogram, is 18. What's the area of each of those triangles? Well, it's half, because we know that area of a triangle is 1/2 a group of the base times the height. So 1/2 of 18 is 18 divided by 2. So each triangle is 9 square centimeters for each triangle. Now, go on to number 13. Divide parallelogram ABCD into 2 obtuse triangles. We need to draw it into 2 obtuse triangles. There's 2 ways we could do it. We could put a diagonal going across from A to C, or we could put a diagonal going across from B to D. The question is, which one of those lines cuts it into obtuse triangles? Well, hopefully you're noticing that it has to have that big open, that angle, vertex B has to have that big open angle. So the answer is we've got to cut it in half from A to C so that that's one big obtuse triangle. And the vertex D has another big obtuse triangle. So we've got to divide it into 2 parts with a diagonal with 2 obtuse triangles. What's the area of each obtuse triangle? How are we going to figure that out? Pause and see if you can do it without me. Well, the first thing is we have to measure. We have to measure how to do it. The base is, I'm using inches again. The base is 6 centimeters. The height is 3 centimeters. Base for the formula for a parallelogram is base times height. So parallelogram area equals base times height. So base times height, the area of the parallelogram, equals 6 times 3, 18 centimeters. Do you see anything? 18 square centimeters. Do you see anything familiar about this work we're doing? Well, hopefully you're noticing it's exactly the same thing that we did up here. We just wrote the diagonal the other way. So now we're finding the area of the obtuse triangles, where up here we made the other diagonal, so we had found the area of the acute triangles. But look at this. The area is still the same. It's still base times height. And how are we going to find it? Each one is half. So we're still going to find the area of the triangles is 1/2 a group of base times height. So that's 18, a half a group, or divide by 2, is 9 square centimeters. Look at that. So both triangles in each parallelogram, Both turned out to be 9 square centimeters, but they are different shapes, but they're still 9 square centimeters. Finally, the last problem. Number 15, draw the 2 different diagonals for parallelogram EFGH. Name the triangles, measure them in centimeters, and find the area of each triangle. I'm going to leave this one for you. Good luck. You can do it. You're going to follow the same pattern that we've been using the rest of the time. Challenge yourself and see if you can do that. And don't forget to check your answer in the answer key. Good luck. We'll do the next half of this lesson tomorrow. See you next time.